Okay, so class, once again, good morning. So, how are you this morning? Class, okay lang mo? Okay, so that's good. How about the others? Ava, Kim, and Shello. Angel. Okay, so that's a good class. I do hope that you are all in good health and in good condition, class. Okay? So, the last meeting we had, so we were able, class, to talk on introduction to hypothesis testing, right? So can you tell me, class, or can you give us some ideas on what you have learned from our previous meeting, or what have you known about hypothesis testing? Or can you give me, class, the different steps on how to conduct a hypothesis testing? What should be our first step when we conduct a hypothesis test? Okay, that's one. You have to state the null and the alternative hypothesis. So take note, class, that your null hypothesis is a statement of equality or a statement of no relationship. So that's what your null hypothesis will talk about. And then how about if your null hypothesis is a statement of equality, how about your alternative hypothesis? It is a statement of an idea. That is a statement, class, of inequality. Again, if your null hypothesis is a statement of equality, your alternative hypothesis is a statement of inequality. At the same time, class, when we talk about relationship between two variables, your alternative hypothesis will state that there exists a relationship between these two variables. Okay? So after stating your null and alternative hypothesis, what comes next? What will you do, class, after stating? You have to identify the level of significance. Okay? So your level of significance, class, or the alpha will help you identify the you have to set the probability of committing the type 1 error. So if you say you can use, class, 5% level of significance, or you can use, for a more strict study or more complicated study, you can set the level of significance to 1%. Okay? So after stating, class, your null and alternative hypothesis and then identifying your level of significance, what comes next? Anybody? Class, what comes next after identifying the level of significance for your study? You have to okay, you are going to get the p-value. So I mean to say, class, at this point you are going to perform now your data analysis. You are going to analyze your data using a statistical software, where in our case we are going to use R. Okay? We are going to run some codes on our data so that we can get the p-value. And then after getting the p-value, class, what will you do next? You are going to class, what are you going to do with your p-value? You are going to use your p-value to an idea. Okay, so thank you, Kim. That's you are going to make decision. So you are going to use, class, your p-value to decide whether you are going to accept your null hypothesis or to reject your null hypothesis. So the condition is that if the p-value obtained, class, is greater than or equal to the level of significance, you are going to accept your null hypothesis. So otherwise, if your p-value obtained, class, is lesser than the level of significance, then you are going to reject your null hypothesis. Okay, that's the fourth stage or fourth step. You are going to state, or you are going to make decision. And then finally, what will be our last step when conducting a hypothesis test? Okay, you are going to state the conclusion. So when you state class your conclusion, make sure that you have answered the question of your research problem. So make sure that you target class the answer for the question class that you are trying to solve. That's the last step of hypothesis testing, which is stating your conclusion. Questions so far, class, or clarifications with what we have discussed last week? Other questions, class? Last my questions. Okay, so if wala class, so this morning I'm going to introduce to you one method or another. We are going to go through class with the hypothesis testing, but in this time we are going to perform class hypothesis test for normality. So what's your idea, class, about this lesson, or what this lesson is all about? Do you have any idea, class? Okay, so if none, you are going to go through class with this lesson for this morning on hypothesis test for normality. So here are our learning objectives. Each of you, class, must be able to identify the different statistical tools and R functions used in performing a test for normality. So when to say, class, in this lesson, you will learn, class, what are those tools, what are those statistical tools used to perform the hypothesis test for normality. Okay, and then after knowing, class, those tools used to perform the hypothesis test for normality, you must also be able to identify what are those functions in R used to perform this hypothesis test for normality. And then finally, you should be able to perform the hypothesis test for normality. So that's our learning objectives for this morning. Okay, so just to recall, class, diba, in our previous lesson on graph, we have discussed, class, about the histogram, right? So again, to recall, class, what does the histogram tells to our audience? Or what data do our histogram convey to its audience or to our audience? Okay, anybody? For example, class, your histogram is shaped like a bell curve. What does it tell about your data? Okay, so that's one. So when your histogram, class, looks like a bell curve, mean to say your data follows a normal distribution. Okay, but then sometimes, class, in addition to graph, we also need to perform hypothesis test for normality, because for instance, if you don't have, class, this large amount of data, well, your histogram would not really look like a bell curve. In that case, there are certainties, okay, that we want to clarify whether this set of data really follows a normal distribution. So in that case, in addition to our histogram, we can perform the hypothesis test for normality to further check whether this data really follows a normal distribution. And that's what this lesson is all about, performing a hypothesis test for normality. Okay, so again, it is this tool is necessary for us to identify whether we are going to go through with parametric test and non-parametric test. Okay, so again, ang test for normality, class, is a prerequisite for us to identify the appropriate statistical tool to use. Okay, so we need to check first whether, class, our data follows a normal distribution or not, because we cannot just use this parametric test unless one of its criteria or all of its criteria, class, has been satisfied. And one of these criteria is at least that your data must be normally distributed. So that's one prerequisite, class, for parametric test. data must be at least normally distributed. Okay? But then, for sample class, after performing our hypothesis test for normality, when we found out that our data is not normally distributed, then we can opt for non-parametric test. Okay? But then again, a test for normality is just one prerequisite. Okay? That must be satisfied before you can use your parametric test. But then for sample class, if your data is not really normally distributed, there are still other conditions that you can that can be satisfied. Like for example, if you have lots of data, then you can use parametric test. Pero kung lesser in data nimo and then dili pa jud normally distributed, then in that case we can suggest you using a non-parametric test. Okay? So again, this lesson class is necessary for us to identify the appropriate statistical tool to use, whether mo go for parametric or we can go for non-parametric test. So again, in a histogram, a normally distributed data looks like a bell curve na distribution. So for instance, if this is our histogram, just to recall class, okay, a while. If this is our histogram, so our data class should follow this bell curve distribution to tell that our data is really normally distributed. But then again, in addition to the histogram, we can perform the hypothesis test for normality to further check our data. So again, in hypothesis test for normality class, we have two statistical tools that we can use. Okay, so these are the two most common statistical tools used to perform the hypothesis test for normality. One class is that we have the Shapiro-Wilk test, and the other one class is the Kolmogorov-Smirnov test. Okay, so these are the two most popular na statistical tools to perform the hypothesis test for normality. Shapiro-Wilk test and the Kolmogorov-Smirnov test. So do this test class looks familiar with you? Have you ever heard class about Shapiro-Wilk test and Kolmogorov-Smirnov test? Or is it your first time to hear these statistical tools? Or was it already mentioned in your research subject? Class, first time pa? Class, are you still there? Okay, first time. Okay, so again, this might be your first time to encounter these terms, but then again, we'll go through this with these different statistical tools. Okay, so let's talk first class about your Shapiro-Wilk test. Okay, your Shapiro-Wilk test class is used to determine whether a sample is drawn from a normal distribution. So again, since these are all statistical tools for test for normality, they will of course help us understand or identify whether a sample is drawn from a normal distribution. So here's the pattern class for our null hypothesis. In our null hypothesis, we should always state that the sample is drawn from a normal distribution. And then our alternative hypothesis is that the sample is not drawn from a normal distribution. Okay? So that's your pattern class to state your null and alternative hypothesis when you perform the hypothesis test for normality. Question class or clarification on how do we state the null and alternative hypothesis for hypothesis test for normality. Class, questions or clarifications? So na subtan class, again, that's your pattern on how you will state your null and alternative hypothesis. And then after that, you are going to set our level of significance depending on what is presented in the given problem. Pero class, I tell you that if the level of significance is not explicitly defined in the problem, you have to assume that it is already a 5% level of significance. Okay? So again, if it is not explicitly defined, use 5% level of significance. So here's how we are going to perform a Shapiro-Wilk test in R. So we have here, class, your Shapiro-test function. Okay, this one. Okay, for a while. Okay, this one, class. Your Shapiro-test is class the R function used to perform the hypothesis test for normality. And then what we're going to pass, class, inside our Shapiro-test function is of course our data set that we are going to use in this Shapiro-Wilk test tool. And then after identifying, class, our data set to be used, we are going to identify which variable are we going to use. Okay, so here is your data set name, and then the column, class, or the variable name that you are going to use to perform your Shapiro-Wilk test. Question, class, or clarification on how we use this function? Class, na question? Okay, so if there's none, so I have here, we'll proceed to class to the next slide. So we have here a problem, class, which states that you were tasked to perform a Shapiro-Wilk test to determine whether the girth of trees, okay, tree here, class, or trees here, this is our data set name, and girth here is a variable of our trees, whether it follows a normal distribution. As stated here, you are going to use a 5% level of significance. Okay? You have question, class, with regards to the example problem which I have presented. So, given that sample problem, how do we state, class, our null hypothesis for this problem? So again, class, first step is that you should be able to state the null and alternative hypothesis. Okay? So, what will be our null hypothesis for this problem? Which variable, class, are we interested in testing for its normality? Class, which variable are we trying to identify whether this variable follows a normal distribution or not? Okay, it is the girth of trees. Therefore, class, when we state our null hypothesis, we should state that the girth variable of trees dataset follows a normal distribution. Because again, our null hypothesis, class, is a statement of normality in this example. Okay, it's a statement that this data or this variable follows a normal distribution. And then of course, how will you state, class, our alternative hypothesis? If you were tasked to state the alternative hypothesis for this problem. Okay, that's right. That girth variable of the trees dataset does not follow a normal distribution. So with that statement, class, you are ready now to take to the next step. So next step, class, is to identify the level of significance used in this problem. So what is the level of significance, class, used in this problem? Class, pila man ang level of significance used in this example, or the alpha value? 5%. Okay, so that's 5%. So to note, class, null hypothesis is given by the symbol HO, and your alternative hypothesis is given by the variable HA. So again, our alpha here is equal to 0.05. So mean to say, class, 5% level of significance, we only allow 5 out of 100 that we are committing a type 1 error. Okay? So that's what the level of significance means. Okay? It's the probability of committing the type 1 error. Okay? And then step number 3, class, is that you were tasked to get the p-value. Okay? And then of course, to get the p-value, we need, class, is statistical software. And then one of the statistical software, class, that we can use is of course the R Studio or the R programming language. Okay, to do this, we are going to use class the shopper.test function, this one, the shopper.test function that we have learned earlier, and then inside the shopper.test function, we are going to pass our name of our dataset, which is the trees, and then pass class the variable, which is our girth. So girth class is a variable or a column of our trees dataset. So with this line of code, when you press enter class with your computer, it will display class this data. Okay? So take note class that trees dataset here is a built-in dataset of R. So therefore, since this is a built-in dataset, you can readily use this dataset to any computer ng IR. Or even perhaps class, you can run this code online. There are websites which allows you to execute R codes. Okay? So from here class, from the output, what we are interested in looking at is the p-value. Okay? This is our p-value that we're going to take out. Okay? So hence class, our p-value here is 0.08893. Okay? So again, this is our p-value. Question class or clarifications? Last questions about the output. So again class, from the output, we are just interested class in getting the p-value because this is what we need when we try to perform our hypothesis test for normality. Question class or clarifications?
Not so.
Okay, from here class, the fourth step is that you were tasked to make decision. So with this p-value, are you going to accept or reject your null hypothesis? Class, are you going to accept your null hypothesis or reject?
Accept, sir.
Okay, so from here, imo itapad class ang level of significance nga 0.05. Imo i-compare, okay? 0.05 and 0.08. When you try to compare the p-value and the level of significance, the p-value class is greater than your level of significance. Since greater siya, the decision is again to accept our null hypothesis. Question class or clarifications nganong we accept our null hypothesis in this example? Class, are there questions? Sabtan class, kanong accept HO ang decision dire? Last questions sa decision.
Not, sir.
Okay. And then finally, what will be your conclusion? Are you going to conclude that the girth variable of today's dataset really follows a normal distribution? Okay, nasyo na noon. Well, anyway, so since our decision class is to accept the null hypothesis, therefore we will conclude that there is sufficient evidence to conclude that the girth variable of the trees dataset follows a normal distribution. So we are going to add class the phrase, there is enough evidence to conclude that the girth variable of the trees dataset follows a normal distribution. So why do we need to add that phrase, there is enough or there is sufficient evidence? It is because class, after performing the data analysis and data interpretation, we really found out that the data really follows a normal distribution. Therefore, to state a conclusion, we should state that there is sufficient evidence or there is enough evidence to conclude that the girth variable of the trees dataset follows a normal distribution. Question class or clarifications? So again, let me just type here. Okay, there is enough evidence to conclude that the girth dot. Okay, that one. It's enough to conclude that the girth variable of the 3-zeta set follows a normal distribution. Question, class, or clarifications about this example using the Shapiro-Wilk test?
None, sir.
Subton, class? Okay, so let's now move to the next slide. So, in addition, class, with our hypothesis test for normality, we can further support our conclusion by presenting a histogram. Okay, so this is our code used to generate our histogram, and then from our histogram, we are going to draw, class, the curve. Okay, so this is our histogram as presented in this slide. So from here, we could really say that a bell curve has been formed in our histogram. Therefore, our data, class, follows a normal distribution. So Mona, class, if you cannot really, if you're not so certain whether this histogram is really presenting to us a normally distributed data, then you need to conduct your hypothesis test for normality. And then from there, you can find out whether your data really follows a normal distribution or not. Okay, so I hope, class, that's clear when using, class, the Shapiro-Wilk test. So let's now move, class, with another statistical tool used to perform the hypothesis test for normality, which is your Kolmogorov-Smirnov test. Okay, so this one, again, this is a tool for hypothesis test for normality. And then, of course, they are used to test whether data follows a normal distribution or not. And then, one good thing, class, about Kolmogorov-Smirnov test is that it can be applied to one sample and two sample data. So, what do I mean when I say, class, one sample data? Okay, when I say, class, one sample data, I mean to say I only have one group. Okay, I only have, class, one group of data. And then if I say two sample data, I mean to say I have two groups of data. Okay, for example, data for group 1 and data for group 2. That's two sample. But then, class, if I say I only have the GPA of grade 9 diamond, that's one sample. If I say, class, I have the GPA for all students from diamond and emerald, that's two sample. Okay, I have two sets of data man. Sabtan, class, ang one sample and two sample data.
Yes, sir.
Okay, so again, ang Shapiro-Wilk test, class, is only limited with R to one sample. If it now deals, class, with two sample data, like we want to check whether these two samples are drawn from our normal distribution, then we can use the Kolmogorov-Smirnov test. And then for one Kolmogorov-Smirnov test, here's our pattern to state the null and alternative hypothesis. Very similar, class, with stating the null and alternative hypothesis for Shapiro-Wilk test. So HO, again, the sample is drawn from a normal distribution. Then, of course, the HA is that the sample is not drawn from a normal distribution. And then for a two-sample Kolmogorov-Smirnov test, here's our pattern. Okay. Okay, one sample pa siya. Okay, so here's how we can perform, class, a one-sample Kolmogorov-Smirnov test using R. Okay. So if in the Shapiro-Wilk test, class, we use the Shapiro-the-test function, for Kolmogorov-Smirnov test, we are going to use, class, this function, ks.test. So ks, class, Kolmogorov-Smirnov.test. Okay? And then, of course, class, we are going to pass your name of your dataset, then the variable that you are interested in testing, its normality. And then we have here, class, since this is a one sample data, we are going to include this argument, p norm. So it is enclosed, class, in double quotation mark. And this is constant. So why do we need to add, class, this constant value? Ang p norm, class, mean to say we are going to check whether our data is drawn from a normal distribution. Since this is only a one sample data, we are going to pass this argument na p norm. This is again class constant. So you don't need to change this argument when you are going to write this code and testing for one sample Kolmogorov-Smirnov test. Ang mag-change ng diri class is this one, a name of your dataset, then the variable, and then this one is your mean, and this one class is your standard deviation. Okay, or this is, I guess this is your variance. Okay, this is your variance class for your data set. Again, this one is your mean, and then this one class is your variance. So you need class to get the mean and the variance for this data set before you can use the Kolmogorov-Smirnov test. Question class or clarification? Class, na questions on how to perform one sample Kolmogorov-Smirnov test? Okay, so let's try an example. Okay? Sorry class. Okay? This is not variance DI, but that's standard deviation. Okay? So for example, given this problem, you were tasked class to perform a test for normality for the height variable of the trees dataset whose mean is 76 with a standard deviation of 6.37. So this time class, we are now going to check the normality for the height variable. So in our Shapiro-Wilk test, we are using the girth variable. But then this time, let's try to test whether the height variable class follows a normal distribution using the Kolmogorov-Smirnov test. Since we are only interested class in identifying the height variable, this now calls for one sample Kolmogorov test. Kay usa raman ka variable ang ato ang gi-studyhan. Okay? Which is your height variable. So again, in this problem, we are going to go through class the different steps. So how will you state class our null hypothesis for this problem? Class, what will be your null hypothesis for this problem?
The height variable follows a normal distribution.
Okay, the height variable of the tree data set follows a normal distribution. And then contrary, that's your alternative hypothesis. It does not follow a normal distribution. So in this example, what is our level of significance used in this problem? Pila may atong gamiton class nga level of significance? We are going to use
5%.
okay, that's 5% because again, it is not defined here, then mag-assume ta nga it is given that it is 5% level of significance. And then step 3, we are going to perform class the data analysis using R. So here's what our code looks like. TS.test, again total R that we are going to perform Kolmogorov-Smirnov test. And then pass here class your dataset name, which is your trees, and then the variable, which is height, then the constant P norm, total R that we are interested, that we wanted to know whether this variable is drawn from a normal distribution. Then 76 here, this is your mean or the average. And then 6.37 classes is your standard deviation. And then from here, press click enter, makakuha na ka og P value. Okay, this is now your P value. So given this P value class, what will be your decision? Are you going to accept your null hypothesis or reject your null hypothesis? Yes, are you going to accept or reject your null hypothesis for this example? Angel? Angel, are you going to accept or reject your null hypothesis? Okay, so i-compare nimo ang 0.05 sa 0.5 4 as 0.7447. So in that case, mas greater ang p-value, therefore, your decision class is to accept our null hypothesis. And what will be your conclusion? Shiloh. And Shiloh, how will you state your conclusion for this problem? Okay, anybody who would like to state the conclusion? Kim?
It follows a normal distributions.
Okay, so there is enough evidence to conclude that the height variable of 3 dataset follows a normal distribution. Okay, question class or clarification for one sample Kolmogorov-Smirnov test. Other questions class that you would like to clarify? So if there's none class, please proceed with a two sample Kolmogorov-Smirnov test. So again class, when I say two sample, I mean to say the data class is divided into two groups. Okay, or in other words, we have two sets of data. So this is how we are going to perform class a two sample Kolmogorov-Smirnov test. Key is the test, again total R, that we are interested in performing a Kolmogorov-Smirnov test. Then of course our dataset name, and then the group 1 data na label, and then the group 2 na data that we wanted to test. Question class or clarification? So let's try this example problem. Okay, Angel, can you kindly read the problem? Okay. So in this example class, we are tasked to determine. Okay. We are tasked to check if the weight distribution is the same across the treatment groups of plant growth dataset. So our dataset here class is plant growth, and then the variable that we are interested in checking is the weight distribution for the treatment groups, for the two treatment groups of plant growth dataset. Okay. So from here class, after identifying your variable, we can now start stating our null and alternative hypothesis. So here's our null hypothesis for this problem. The weight distribution is the same for both treatments, for treatment 1 and treatment 2. So mean to say class, the distribution of weights now is the same for those plants under treatment 1 and treatment 2. And of course, contrary anania is our alternative hypothesis, which states that the weight distribution differs for both treatments. Questions class or clarification?
None, sir.
So in this case, we are still class testing the distribution of weights. Whether same ba ang distribution nila o dili ba pareha ang distribution of weights. So don't get confused kung mag-two sample na ta for hypothesis test for normality. We are only testing class ang distribution. Whether same ba ang distribution aning nga variable for these two sets of data. And then step number 2 is to state class your level of significance. So what will be our level of significance for this problem? Are we going to use 1% or 5% level of significance?
5%, sir.
Okay, since a problem class wala nag-state sa level of significance, therefore again, ma-assume ta that it's 5% level of significance. And then from here, step number 3 is to analyze your data so that we can get the p-value. Okay, so here's the process class. So plant growth, we need to unstack our data because again, we cannot just use the unstack form or the stack form of plant growth data set. So after unstacking class, we now have these two variables, plant growth 2, the name of our data set, and then it has two groups, treatment 1 and then treatment number 2. And then from the after performing class, after pressing enter, we are going to get this p-value. Okay, so this is now class your p-value obtained. So if I say class, I want you to round the p-value to the nearest thousands, what will be its value? Again class, what p-value are you going to give me if I say round the p-value to the nearest thousands? What p-value are you going to give me? Okay, that's right, 0.002. Okay, so be careful class, ana nga instruction. You have to take a look up to what decimal place ang ipangita sa example problem. For in this case, since wala sa identify nga up to ano nga decimal place, then you are assumed to use this entire nga value. So since we do not have class our p-value, what will be our decision? Are we going to accept your null hypothesis or reject your null hypothesis? Class, what will be your decision? Accept or reject ang null hypothesis? Class, what will be your decision if you're...
Reject the null hypothesis.
Okay, so ana, ato i-compare ang 0.05 sa 0.002. So in that case, mas gamay jud class ang p-value. Since gamay class ang p-value, well of course, the decision is to reject our null hypothesis. And what can we conclude if we reject our null hypothesis? Class, what can we conclude? Anybody? Okay, the weight distribution across the two treatment groups is different. Okay, so there is enough evidence to conclude that the weight distribution between treatment 1 and treatment 2 is significantly different. So I mean to say class, again in short, there is a difference in the weight distribution for treatment 1 and treatment 2 groups for the plant growth data set. Questions class or clarifications if there are?